Let's look at multiplying and dividing. The value from your question with the fewest number of significant digits determines the number of significant digits that your answer must include. So we have an answer like 2.5 times 1.75. So when we multiply those, we get an answer of 4.375. But how many significant digits are there in my question? How many here? Two. How many here? Three. So our answer must have the same as the least number in my question. My least number is 2. So which numbers do I want here?
4. And you have to round it.
So I want the 4.3, but I don't jump to saying 4.3. I must look at the immediate number after it. I don't care about the one after that. It's only the one number immediately following the last number I'm keeping. Okay, so answer has 4 significant digits, but the least number of significant digits in my question is 2. So we're going to look at the one immediately following. Okay, so we want to look at the one immediately following. Because it's a 5 or greater, our answer can either be 4.3 or 4.4. But because that number right after that 4.3 is a 5 or greater, the number gets rounded up to 4.4. Okay? Adding and subtracting. The value from your question with the fewest number of decimal places determines the number of decimal places that your answer must include. So we're going to add all these values, and we get 1.2 plus 30.41 plus 0.005. And we get a value of 31.615. So, what are the least number of decimal places in my question? How many in our first set of numbers?
2.
Decimal places.
Oh, 1.
1 decimal place. Here, 2 and 3 decimal places. So the least number is 2. So what we want to do is answer has 3 decimal places, but the least number is 1 decimal place. That's what we want. Okay? So what we're going to do is we're going to identify the 1 decimal place. But we're not just going to identify the decimal place. We're going to identify everything in front of that as well, because those are numbers that are included. So the number is 31.6. Now, the number can either be 31.6 or the number can be 31.7. Okay? Yeah.
How does it become 31.7 if the number after it?
Oh no, we're assuming what it can be. Yeah, so whenever we're rounding, this is the problem with rounding. It's trying to identify what are the possibilities that we can have. We can only have one of 2 things, because one answer, and I thought I heard someone whisper it, as 32. But how many decimal places does that include? None. Right? So we cannot round it off to 32. Right? So the only possibility is we keep the value or it changes. But what part changes? And what we have to identify is it's that last so-called uncertain digit is what can change, depending on, as you said, is the number 5 or greater. So is that number that we're looking at immediate? Look at where the 5 is. We don't care about that digit. It's the one immediately following the last set that we're keeping. Okay? So the number does not get rounded up. The number stays with the digits that we wanted to keep, 31.6. Okay. So remember, identify those decimal places that you need. Look at the number immediately following the last digit that you are keeping to see whether or not it needs to be rounded off. And this time, we didn't need to round off. Okay, scientific notation. Sometimes numbers are too big or too small to be written out. Therefore, we use scientific notation to state them. Keep in mind that scientific notation are written in the form of m times 10 to the power of n. Okay, so this is what it's going to look like. Now, this value of m, okay, can be any set of number, but the number must be between 1 is less than and equal to that m value, which is less than, but not equal to 10, which means that m value must always be either 1, 2, 9.9, forever. It can never be 10, it can never be 11, it can never be any number that is greater than 9.9 repeater. Okay, so now the n value, this little exponent, that times 10, the n is a positive value if the number is greater than 1. Okay, so 4 times 10 to the power of 5 means that we have a number that is greater than 1. So it's a big number when we have an n that is, the n value is positive. When the n value is negative, same example, but we're going to add a negative to that n value, negative 5, and we get a number that is considered smaller than 1. Okay. So, scientific notation tips. Remember that the n value of scientific notation must be a number in between 1 and 9.99 forever. Okay, repeat it. Examples of numbers that are not in scientific are as follows. 12.5 times 10 to the power of 3. Why is that not considered scientific notation? Yeah, it's greater than 9.99. So what do I have to do to change it to scientific notation? Move the decimal. So I'm moving it in this direction to make it 1.25. And now notice my n value is between the values I want. Times 10. How does it change the exponents? I've just added one more decimal place. So my exponent now is to the power of 4. Okay. Another one. So n value greater than 10. 0.4 times 10 to the power of 6.
It's smaller than 1.
It's smaller than 1. Our n value is smaller than 1. Okay. So which means, how do I change it? I move the decimal in this direction. So my value is here now. 4 times 10. But I'm subtracting an exponent, one of my n values, so it becomes times 10 to the power of 5. Okay? Scientific notation tips for more. If you cannot achieve the correct number of significant digits, convert your answer to scientific notation. What does that mean? So convert the number 30 so that it has 2 significant digits. How many significant digits does the number 30 have? 1. Right? It has 1 significant digit. How do I make it have 2? How many significant digits? 2. 3.0. One common thing that you can do to add significant digits is this. Add the 0.0 to the end, right? But, are the two values the same? First of all, 30 and 30.0, yes or no?
Yes.
Yes, but we went from how many significant digits? 1, 2, 3 now. Right? We added that 0.0. We added that 0.0. So the only way to change something like that to the right number of significant digits that we need for our answer is to convert it into a scientific notation. So that's your tip. If you cannot change your answer like that to scientific notation, it's like this. Your answer, let's say you calculated, it came out to 10,000. But your answer must be in 2 significant digits. How do you change 10,000 to 2 significant digits when, well, the only other option I can think of right now is to add this, but now I'm including all these as significant. I only want 2 in my answer. So we put it into scientific notation and we get 1.0, right? There's 2 significant digits times 10 to the power of
4.
4. Okay, so now we showed 10,000 as 10 is still 10,000, but we wrote it down in scientific notation to give us the right number of significant digits that we need.